Can an artificial black hole be created in laboratory conditions? If so, how small is the black hole that could be made? The answer to this is no. With any current or remotely workable technology, black holes are created by certain dying stars. A star with a mass greater than 20 times the mass of the Sun may produce a black hole at the end of its life. During the dying stage of a star, it runs out of nuclear fuel, gravitational force becomes dominant, and the stuff in the core of a star is compressed even further. Due to the massive size of the star, the core starts collapsing under its own weight. Later, it explodes as a supernova. Supernova is the most violent place to be in, where the outer parts of the stars are thrown violently into space, whereas the core of this star instantaneously collapses under its own weight. If the remaining core is greater than 2.5 times the mass of the Sun, then a black hole is created. Theoretically, you can create an artificial black hole by getting a large amount of matter and energy into a very small volume. The most viable method to do this would probably be to use massive, huge particle accelerators. The difficulty is that the black holes are super dense and smaller, and the less massive they get, the less denser they are within. But there are limits on how dense matter can get. If we take a close look at the atomic nucleus, then we would notice that all of the matter of an atom is closely packed. This is the threshold level where the density of matter can be attained. For example, 1,018 kilograms per m3, which is equivalent to 1,000 million times denser than that of a water molecule. Interestingly, this density is the same of that of a neutron star. So basically, these are giant atomic nuclei. Currently in astrophysics, there is a big debate on the minimum size of a black hole. Majority of the physicists claim that the minimum size should be around 2 × 10 to the negative 22nd power. While this figure seems small, mind you, it's very difficult or probably impossible to get that much mass and energy into such a tiny region. A black hole consisting of this mass would be about 10 to the negative 47th power across. Now this is smaller than a single electron, about 10 to 15 m. A particle can't concentrate energy smaller than the particle itself. So, a particle accelerator needs to accelerate particles almost to that of the speed of light. This means that you should require an enormous amount of energy to get a collision which is sufficient to create a black hole. The colliding protons would need to have a gamma factor. The gamma factor should be in the order of magnitude 10 to the 37th power, the mass of a small mountain range. For comparison, few grams of matter is sufficient to blow up an entire city. Tremendous amounts of energy is released when we transform matter to energy. There isn't anything in the universe that behaves like a black hole. They twist space and time and are weird in a lot of ways. Even if you can create an artificial black hole in laboratories to study Hawking radiation, unfortunately, you won't be able to recognize them. Gravitational lensing and space-time stretch cannot be studied in lab conditions. The black hole-like conditions can be simulated in supercomputers. If we are successful in the near future, then probably we could get a way to create tiny black holes formed at lower energies. If the Large Hadron Collider is successful enough in creating a tiny black hole, then these black holes would shrink faster than they grow by gobbling up matter. So these black holes would die within a fraction of a second before they could engulf significant amounts of matter. Conclusion: even if we are successful in creating a tiny black hole in lab conditions, these black holes would be completely different to what's usually created naturally. You would never know that the black holes were being studied. If you've liked Inkstall's edutainment, then go to inkstall.in and sign up for free. Producing our videos takes a lot of time. If you'd like to support Inkstall, you can do so on patreon.com/Inkstall. Please refer the link below to buy Inkstall's book on space, time, and beyond.